Okay, so we're gonna talk about logical operations, which is something that you're gonna need a lot for your project, and how to apply these logical operations in anonymous functions. Um, so, for example, here we can create a variable called t, and we're gonna give it a number of -1. Now we can ask Matlab to determine whether a statement is true or false. In this case, we're going to ask it, okay, is t smaller than 0? Then is t smaller or equal to 0? Or is t greater than 0? So we're going to run this and walk through it to see what the outputs are. So the first step is we create a variable called t, and it's going to have a value of -1. Now we're going to ask, create a w, and is t smaller than 0. So if the statement is true, MATLAB is going to output a value of 1. So we see we get w, and it's going to give a value of 1. Now we're going to ask it, is t smaller or equal to 0, which is still true, right? T is -1, which is smaller than 0. So it's going to give us a number 1 again. Now we're going to ask it, is t bigger than 0? In this case, t is not bigger than 0, t is smaller, so we're going to get an output of 0. What this is going to allow us to do is to turn on or off parts of a function depending on the value of t. So let me explain that a little better by creating an anonymous function. So now we're going to apply these logical operations to anonymous functions. So what we've learned so far is we have a statement, and if it's true is 1, and if it's false is 0. So let's imagine that we want to create a step function. For those of you who don't remember, a step function it looks like a step, and it has a constant value of, say, 1, and then it can drop to 0, and then it can go to 1, and it's going to look like an impulse, right? So it's going to go up to 1 for a certain period of time, then it's going to go down to 0, then it's going to go 1 to 1 again. That's a one-step impulse. Now we can create inputs like this with logical operations in anonymous functions. So for example, let's say that we want an impulse of size 1. So we can say a is equal to 0, and then b is equal to 1, and we want the impulse to activate at a particular time. For example, we want the function to be 0 from time 0 to 5, and then 1 from 5 to 10. So then how we would do this is we create an anonymous function, how we've learned before, and anonymous function is going to depend on the time, because I'm going to activate it at time equals 5. So then what we're going to do is we're going to say, okay, I want it to be 0, which is a. Actually, let's make this 1 and 2 so it's more clear. Okay, so I want it to be 1, and I want it to be 1 when time is smaller than 5. So then what we would do is we'd say, okay, to make time, which is t, smaller than 5. We can say smaller or equal than 5. So what this is going to do is it's going to, when t is smaller or equal to 5, this is going to be 1 because it will be true. And then a is just 1, so this whole function is going to be 1, right? Now we can add the second statement, which is going to be, okay, now make the function y be equals to b when the time is bigger than 5. So now if we look at this statement carefully, and I know this is not very easy to understand for the first time you look at it, but so if we divide this into 2 and just forget about this part initially, if this statement is true, this has a value of a. If this statement is true, the whole function has a value of b, because if t is, for example, 6, this statement is going to be false, so it's going to have a value of 0. So this whole piece at the beginning gets cancelled out, and then you're only going to left with b. And if t is greater than 5, then this is just going to have a value of 1. So let's give that example. For example, if t is equal to 0, then we're going to have y equals to a times 1, because t is equal to c, it's smaller than 5, so this has a value of 1 because it's true, and then plus b times, and now t is 0, which is smaller than 5, so this statement here is 0. because it's false. Okay, so now if we understand that, we can now use fplot as we have done before and just tell MATLAB, okay, I want you to plot the function y. Let's plot it from 0 to 10. And now let's see what happens. So now, oh, where did my function go? Did I plot it? Hold on. Okay, let's run it again. Okay, so now I have my function here, which has a value of 1 from 0 to 5, and then it has a sudden increase to a value of 2 from 5 to 10. Does that make sense? It never reaches a value of 3 because you never get A to actually add to B. It's going to be only A when t is smaller than 5, and it's going to be only B when t is bigger than 5. So I understand this is not very straightforward, so feel free to put comments in the video, put comments on the piazza, or just send me an email if this is not very clear, because you will need this for your project, and it's important that you understand how these logical statements work. We're gonna see more on how to use these logical statements in your project in the next video, which is gonna be only about the project itself. I think that'll be it. I'll see you next time.